Imagine walking into the chemistry examination hall and you were given an unknown white mixture to identify. No label, no clue, just reagents and your observation skills. Most students panic at this point, but in this practical video lesson, I will show you how to identify a mixture of lead carbonate and starch with the use of standard laboratory reagents step by step like a professional chemist. In this video lesson, we will conduct tests on the mixture, the filtrate, the residue, the confirmatory test on the cation, which is the lead ion, and the anion, which is the carbonate ion, and starch identification. And we're also going to record the outcome of our experiment using the normal laboratory format, which is test, observation, and inference. So if you're preparing for WAEC, NECO, A-level, or any chemistry practical exam, this video is a must watch for you. You're welcome back to Organotope Chem Clinic, where chemistry becomes simple, practical, and unforgettable. Our unknown sample is suspected to contain lead carbonate and starch, so we will identify them systematically using mixture tests, filtrate tests, and residue tests. As we commence this practical exercise, note that observation is what you see and inference is what it means. Moving on, can we observe the appearance of the given sample? We have a white powdery sample. Since we do not conduct any test on the sample, we are not expected to state an inference for this. Moving on, the next test is the dissolution of sample C in distilled water and stir. How do we conduct this? We add distilled water to the sample given and we stir using the glass rod. It can be observed that sample C is insoluble in water and white cloudy suspension forms. So we can have our inference as what? C is an insoluble substance. Okay, if it is revealed in the question that C is a mixture of substances, then the inference will be C is a mixture of colloidal and immiscible substance. Moving on, can we consider the next question, B Roman figure 2? We have to add dilute HCl to the sample C and we allow the gas to pass through lime water. Then finally we carry out a litmus test. What will be our observation here? It can be observed that effervescence occurs and a colorless and odorless gas is evolved, which turns lime water milky. So which gas turns lime water milky? That's right, we have our CO2 is evolved. So for the inference, we have CO2 from CO3 2-. So that is the gas. So the gas that turns lime water milky is CO2, carbon 4 oxide. We also conducted a litmus test and it was observed that the gas turns damp blue litmus paper red, which indicates that the gas is acidic. So we write here, gas is acidic. Make sense? We've been able to confirm the carbonate ion, CO3 2-. Can we proceed to determine the metal ion? In order to determine the metal ion, also known as the cation, in this sort analysis, we have to prepare a filtrate and residue from the mixture. So we have to carry out the process called filtration of our mixture. And this will lead us to the next test. In C Roman figure 1, we have to add dilute HNO3 to our fresh sample C. Then we stir properly and we can then filter the mixture in order to get our filtrate, which we are going to use to conduct the test for the cation present, which is the metal ion. It can be observed from this test that effervescence occurs, which is as a result of the libration of CO2. When nitric acid reacts with our sample, it results into the libration of CO2. So the effervescence that we have is as a result of the libration of CO2. Since the gas has been tested here, so we know it is CO2. So CO2 from CO3 2-. Okay, and in the process, a white solid partially dissolves and a clear filtrate is observed. And we can as well observe an insoluble residue which remains in the filter paper. We expect to divide the filtrates gotten right here into different portions in order to carry out the analysis for the presence of metal ion. So we have the next test, which is we are to add sodium hydroxide to the first portion of the filtrate in drops and then in excess. So what do we observe? When sodium hydroxide is added in drop, a white chalky precipitate forms, while the precipitate becomes soluble in excess sodium hydroxide. This shows the presence of which metal ion? That's right, we have Pb2+, which is lead ion present. Make sense? Moving on to the second portion of our filtrate, can we add ammonia in drops and then in excess? It can be observed that the white chalky precipitate is formed when ammonia is added in drops and the precipitate remains insoluble in excess ammonia. So what inference can we deduce from this observation? From this observation, we can have Pb2+, Al3+, or calcium 2+ present. So for the inference, we have lead 2+, aluminum 3+, calcium 2+ present. Moving on, can we take the third portion of our filtrates, add dilute hydrochloric acid to the filtrates, then the solution is heated. Can we observe this closely? It can be observed that a white chalky precipitate is formed on addition of hydrochloric acid, while on heating, the precipitate dissolves to form a colorless solution. Can we allow the solution in the test tube to cool so that we can carry out the observation of the metal ion present? Wow! It can be observed that white precipitate reappears on cooling. The colorless solution that was formed on heating now resulted into a white precipitate on cooling. Since the white precipitate reappears on cooling, then so which ion conforms with the observation that we have right here? That's right, it is lead 2 ion. So we can have it as Pb2+ confirmed. Okay, note that for the practical chemistry examination, you are expected to have all necessary reagents for qualitative analysis. So in this particular sort analysis, we have the first confirmatory test for lead 2 ion. The confirmatory test was conducted by adding hydrochloric acid to the filtrate and then heated. It was observed that a colorless solution was formed, and after that we have the reappearance of the white precipitate on cooling the solution in the test tube. Since all necessary reagents are actually provided for the salt analysis, we can consider another confirmatory test for lead 2+. Since it has been tested that lead 2 ion is present in the mixture, we can also have a solution to confirm further that we have the lead 2 ion in the solution. So we can make use of the potassium iodide. Let's take another portion of the filtrates, which is our fourth portion. Add potassium iodide, then observe closely. And also we can use the potassium chromate in place of the potassium iodide. It tends to give similar observation. So on adding the potassium iodide, a bright yellow precipitate forms, while on adding the potassium chromate, a yellow precipitate is formed. The yellow precipitate formed in this particular test confirmed the presence of lead 2 ion. So we have Pb2+ confirmed. So we can have this as the second confirmatory test for lead 2 ion. This test was carried out by adding potassium iodide or potassium chromate to the fourth portion of our filtrate. So the yellow precipitate formed confirmed the presence of the lead 2 ion. Can we conduct the next test? Let's take a small portion of the residue gotten from the filtration. So we take the small portion and it is added into the test tube. Add small quantity of water, then we can heat. On heating for a few seconds, it can be observed that a thick gelatinous paste is formed. So we have thick gelatinous paste forms, and this shows the presence of starch. So we can have our inference as starch is present. Okay, that reveals the presence of starch. So I call this test hot water test for starch. Moving on, we have the last test to be conducted on the residue gotten from the filtration process. The test is iodine test. We are going to add iodine solution to the white residue on the surface of the paper, and we are going to observe the color change. It can be observed that a blue-black coloration forms on addition of iodine solution to the white residue. So we have blue-black coloration form, blue-black coloration forms. This confirms the presence of what? Starch. That's correct. We have starch is confirmed. So the confirmatory test for the presence of starch is the iodine test, which gives a blue-black coloration. Make sense? We can recall that in the mixture test, the anion was confirmed. And what is the anion gotten from the mixture test? That's right, we have the carbonates. Okay, and from the filtrate test, we carried out the meta-ion confirmation. And what meta-ion was gotten from the filtrate test? Yes, we have the lead-2 ion, Pb2 plus. Okay, and also from the residue test, we were able to confirm the presence of which compound? That's right, we confirmed the presence of starch. From the interaction between the cation and the anion, from this salt analysis, we can confirm that the salt is PbCO3, that is lead carbonate, lead-2-carbonate 4. So the salt is lead-2-carbonate 4, and the other substance mixed with the lead-2-carbonate 4 is the starch. Therefore, we can conclude that the unknown mixture contains lead-2-carbonate 4 and starch. So the mixture given contains lead-2-carbonate 4 and what? Starch. Make sense? Interesting. The bright yellow precipitate formed is one of the strongest confirmatory tests for lead-2 ion. Note this for your exam. In this salt analysis, we did not consider the silver nitrate test because the silver nitrate test is unique for halides, and we do not have halides in this particular mixture. That is, the chloride, the bromide, the iodide are actually absent in this particular mixture. Since the halide ions are absent in this particular mixture, it will give no visible reaction for the silver nitrate test. Also, the barium chloride test is unique for sulfate ion. And since there is no permanent white precipitate formed, we do not have sulfate ion in this particular salt analysis. So the barium chloride is unique for sulfate ion. So sulfate is absent in this mixture. Therefore, the barium chloride test is not essential for this salt analysis. If this practical guide helped you, hit the like button and subscribe to Organotope Chem Clinic for more chemistry practical secrets. And comment below which chemistry practical topic should I teach next. I wish you all the best in your chemistry practical examinations.